In this video, I am going to find the Fourier cosine transform, of f of x is equal to 1 by a square plus x square. Hence, derive Fourier sine transform of phi of x is equal to x by a square plus x square. Solution. Function is given function is f of x is equal to 1 by a square plus x square. For this function, I have to find out Fourier cosine transform of function f of x is equal to, the formula is 0 to infinity f of x cos px into dx. That is equal to integral 0 to infinity f of x is equal to 1 by a square plus x square into cos px dx. This is the Fourier transform of function f of x. Let it be I. This one is I. I is equal to Fourier cosine transform of function. Differentiate the above equation with respect. Differentiating above equation with respect to p on both sides. Differentiating above equation with respect to p on both sides. This is the procedure I used to solve this problem. Differentiation di by dp is equal to integral 0 to infinity 1 by a square plus x square. This is the constant one. Di by dp of cos px into dx. That is equal to integral 0 to infinity 1 by a square plus x square. Differentiation of cos px is minus sin px. Px, the differentiation is with respect to p is x into dx. That is equal to 0 to infinity minus, here minus sign, minus x sin px by a square plus x square into dx. Here x square term is there. That is the reason numerator and denominator is multiplied with x. Minus here 0 to infinity, here minus here 0 to infinity x square sin px by x into a square plus x square dx. That is equal to minus 0 to infinity. A square is added and subtracted. x square plus a square, adding a square and subtract this a square sin px by x into a square plus s square into dx. That is equal to minus 0 to infinity x square plus a square, here minus sign, by x into a square plus x square into sin px dx, here minus a square 0 to infinity 1 by x into a square plus x square sin px. That is equal to 0 to infinity x square plus a square by cancel. Therefore, sin px by x dx minus a square 0 to infinity sin px dx by x into a square plus x square. We know this is the d I by dp is equal to minus of pi by 2 sin px integral 0 to infinity sin px by x dx is pi by 2. We know that this one is minus a square integral 0 to infinity sin px by x into a square plus x square dx. Here minus pi by 2 minus into minus plus a square 0 to infinity sin px by x into a square plus x square into dx. Again, differentiating above equation with respect to p. Second integration. Differentiating above equation with respect to p. That is equal to d square I by dp square. Differentiation of minus pi by 2 is constant, that is 0 plus a square integral 0 to p. Differentiation of sin px is cos px. Differentiation of px with respect to p is x by x into a square plus x square into dx. This is a d square I by dp square is equal to a square into integral 0 to infinity cos px into x. The x cancel, cos px by a square plus x square dx is, see this one, this one is integral 0 to infinity cos px by a square plus x square into dx is I. Substitute I here. This is the a square into I. D square I by dp square minus a square I is equal to 0. D by dp is equal to capital D, that is equal to d square I minus a square into I is equal to 0. d square minus a square into I is equal to 0. D square minus a square is equal to 0. D is equal to plus or minus a. The solution of the above differential equation is the general solution is the general solution is given by I is equal to C1 e power AP plus C2 into e power minus AP or PA. This is the general solution. We know that I is equal to integral 0 to infinity. I is equal to integral 0 to cos px by cos bx by a square plus x square into dx. Integral 0 to infinity, substitute I cos px by a square plus x square dx is equal to c1 into e power ap plus c2 into e power minus ap. Let p is equal to 0. Let p is equal to 0. Cos 0 is 1. Integral 0 to infinity. Cos 0 is 1. Dx a square plus x square c1 into c1 e power 0 is 1 because let p is equal to 0 plus c2. Integral 0 to infinity dx by a square plus x square is 1 by a tan inverse x by a. Integral is 0 to infinity c1 plus c2. 1 by a. Substitute infinity, tan inverse infinity is pi by 2 minus 1 by a tan inverse 0 is 0. That is equal to c1 plus c2. Therefore, c1 plus c2 is equal to pi by 2a. This is the equation 1. Again, consider I is equal to c1 e power ap plus c2 into e power minus p. di by dp. Differentiate above equation with respect to p. di by dp is equal to c1 e power ap is e power ap. Differentiation of ap is a plus c2 into e power minus pa is e power minus pa. Differentiation of minus pa with respect to p is minus a. We know that di by dp value is here. Di by dp value is minus pi by 2 plus a square 0 to infinity sin px by x into a square plus x square dx. Substitute di by dp value in that expression minus pi by 2 a square 0 to infinity sin px x a square plus x square dx is equal to c1 e power ap into a minus c2 into e power minus ap into a. Let p is equal to 0. P is equal to 0 means sin 0 is 0, the entire term is 0. That is equal to minus pi by 2 is equal to c1 e power 0 is 1, c1a minus c2a because p is equal to 0. This is the equation 2. Solve equation and equation 2. We know that from equation 1, c1 plus c2 is equal to pi by 2a. This is the equation 1. Solve this one. From equation 2, c1 minus c2 is equal to minus pi by 2a. From 1. From 2, c1 plus c2 is equal to pi by 2a. Both are added. C2 C2 cancel. 2c1 is equal to 0. C1 is equal to 0. C1 is equal to 0. We know that C1 minus C2 is equal to C1 minus C2 is equal to minus pi by 2a. Substitute C1 is equal to 0 in that expression. C2 is equal to minus pi by 2a. Therefore, C2 is equal to pi by 2a. The solution is the solution I is Fourier cosine transform of f of x. Fourier cosine transform is C1 e power ap plus c2 into e power minus ap. But c1 is equal to 0. C1 is equal to 0. The entire term is 0. C2 is pi by 2a e power minus pa. This is the Fourier cosine transform of some function. Given function is 1 by a square plus x square is pi by 2a e power minus p. From this value, you have to deduce, find the hence derive Fourier sine transform of function x by a square plus x square. Fourier sine transform of x by a square plus x square. That is equal to Fourier transform of x into 1 by a square plus x square. This is the Fourier sine transform of x into 1 by a square plus x square is x into f of x. We know that some formula, general formula is Fourier sine transform of x into f of x is equal to minus dA by dP Fourier cosine transform of f of x. This is the Fourier sine transform of x into f of x is 1 by a square plus x square minus d by dP. Fourier cosine transform of fc into 1 by a square plus x square is pi by 2a into pi by 2a into e power minus pa. That is equal to minus d by dp. Pi by 2a is a constant term. Bring outside. Pi by 2a minus pi by 2a differentiation of dp e power minus pa minus pi by 2a e power minus pa d by dp of minus pa. That is equal minus pi by 2a e power minus pa. This is minus a. Finally, this a and a is cancelled. That is pi by 2 into e power minus pa. In this problem, I have derived two expressions. Fourier cosine transform of 1 by a square plus x square is pi by 2a e power minus pa. Second one is Fourier sine transform of x by a square plus x square is equal to pi by 2 into e power minus pa. In objective questions, given Fourier cosine transform values pi by 2a into e power minus a, find out this Fourier sine. By using this relation, we have to find out this one, x by a square plus x square. If you like this video, please subscribe the channel for further updates. Thank you.